Okay, now I'm gonna try to find acceleration of that point P. In the previous part, we found the velocity of P, the way we did it. The actual location of point P is RP, which is gonna be equal to location of the origin of the moving coordinate plus R. And again, keep in mind, R is a vector in the moving coordinate. So taking derivative of this R is gonna be a little bit problematic. So this was the equation. By taking derivative of that, the derivative of RP is gonna be the actual velocity of P. Derivative of RB means the velocity of B. That was easy. But when we are taking derivative of R, it's gonna be taking, it means we need to take a derivative of R in this coordinate, as I showed you before in the previous videos, which means the relative velocity of P in this coordinate, but we had to add this term to it too, to make it mathematically correct. We need to add omega cross R. So this is a general rule, and we can prove it mathematically. If you have a vector in a moving coordinate, whenever you are taking derivative of it, you need to take a derivative of it in the moving frame, then add omega cross that vector. Okay, that's the general rule. So if I take another derivative of this equation, I'm going to be able to find the acceleration of point P, right? Probably this is going to be the most complicated equation that you have in this course. So don't panic. Let's take the derivative of this equation together. Derivative of velocity of P means acceleration of P. That's simple. Is going to be equal to derivative of velocity of B means acceleration of B. So this was simple too. Plus VREL. So keep in mind VREL is the velocity of this point in the moving coordinate. So this is a vector in this moving rotating coordinate. So taking derivative of it is going to be a little bit more complicated than usual. So if you have a vector in the moving coordinate, to take a derivative of it, first you need to take a derivative of it in the moving coordinate. So which means the derivative of the relative velocity in this coordinate is going to be acceleration of this point in this coordinate, which I'm going to show it with AREL. Again, AREL means acceleration of this point in this rotating coordinate. So what's the physical meaning of that? If you sit on this coordinate and rotate with it, look at point P. Point P is going to have some velocity and acceleration in your eyes. The velocity you are seeing about point P is that VREL, and the acceleration you are seeing for point P is going to be that AREL of point P, acceleration in this coordinate. But again, because this is a vector in that moving coordinate, whenever you are taking derivative of it, we need to add this term to it too, angular velocity of the coordinate times that vector, VREL. Plus, taking derivative of this part. Derivative of omega is going to be alpha, angular acceleration of this coordinate, plus omega cross derivative of r. And if you remember, we showed the derivative of r is going to be VREL plus omega cross r, using the same rule. So we need to cross product omega to both of these. If you do that, we are going to have omega cross VREL here and also another omega cross VREL here. And just rearrange it, we are going to have acceleration of P is equal to acceleration of the origin of the coordinate plus acceleration of point P in the rotating frame plus omega cross r. Omega again is angular velocity of this coordinate plus alpha cross r plus 2 times omega times vrel. So this is the most complicated equation, as I told you, you have in this course. It is complicated at the beginning, but you can use it a few times and solve a few problems. It's gonna, you're gonna feel more comfortable about it. So just to recap, if you have a point, we should show it in the moving coordinate, in the moving and rotating coordinate. To find the acceleration of that, you need to use this equation. Acceleration of the origin of the coordinates plus vrel, which means acceleration of this point in the moving coordinate, plus these 3 terms. Just a few important points. Again, because we are in 2D, you can always replace this with negative omega squared times r. Here we have 2 cross products, and usually doing cross products is a little bit confusing. But in 2D, only in 2D, only in surface. If we talk about 3D, this is not going to be correct. But in 2D, you can replace omega cross r with negative omega squared times vector r. Omega squared is not a vector. And also, this part, which is a kind of a weird part, this is Coriolis acceleration. So if you hear or see some Coriolis acceleration, it means 2 times omega cross vrel. We are not going to go to the details of the physical meaning of this Coriolis acceleration. But for now, just keep in mind, this term is Coriolis acceleration, just a name.